Hello everyone, today we are going to explain you that is it possible to build a civilization on Mars, and we hope the information will be beneficial for you, so let's go.
In the stillness of night, when the noise of the world softens and the sky reveals its ancient truths, there is a single point of light that draws the gaze more than most. It does not shimmer like the stars, nor glow with the calm whiteness of the moon. Instead, it burns with a subtle fire, a red ember adrift in the darkness. To the naked eye, it seems almost alive, flickering faintly as though its heart still smolders. This ember is Mars, Earth's closest planetary neighbor and humanity's oldest companion in the skies. For thousands of years, long before telescopes sharpened our sight or rockets pierced the stratosphere, Mars lived within human imagination. The Babylonians named it Nergal, a god of fire and destruction. To the Egyptians, it was Horus the Red, an eye that never blinked. The Greeks called it Ares, embodiment of war. And to the Romans, it became Mars, god of conquest, patron of armies, symbol of unyielding power. Its blood-colored glow haunted ancient skies, weaving itself into prophecy and fear. Wherever humans lived, they saw Mars not as a planet, but as a sign, a celestial reflection of struggle, violence, and fate. But time changes the eyes with which we see. As civilizations advanced, the mysteries of the heavens transformed from omens into questions. What was this restless red wanderer? Why did it move differently than the stars, sliding slowly across the constellations? When Galileo turned his crude telescope skyward in 1609, Mars revealed itself as a disk, not a star at all, but a world. The illusion of divinity began to fracture. Slowly, humanity realized that Mars was not simply a distant light. It was a place. And with that realization came the seed of a dream. The dream of crossing space itself. Mars has always seemed both familiar and alien. From afar, its deserts appear sculpted by the winds, much like those of Earth. Polar caps gleam white, reminiscent of the Arctic. Its length of day is almost identical to ours. Its tilt echoes the rhythms of seasons. Mars feels close, kin-like, as though it is Earth's younger sibling. Yet the closer we look, the more unforgiving it becomes. Its air cannot be breathed. Its nights plunge to depths of cold that freeze metal. Its land is poisoned with chemicals that turn sustenance into toxin. Mars is, at once, a mirror of Earth and its opposite, a reflection of what a planet can be when stripped of its warmth, its water, and its life. And yet, despite its hostility, despite its silence, Mars continues to call us. Perhaps it is the nearness. Across the vast gulf of space, most worlds are unimaginably distant. Jupiter, Saturn, Neptune, magnificent but remote, unwelcoming giants of gas and storm. Venus lies closer, but cloaked in death, a furnace where the atmosphere crushes steel and rains acid from the clouds. Mars, by comparison, seems almost gentle, a place just beyond reach, difficult but not impossible. Its deserts beckon us with a strange familiarity, whispering that with enough determination, with enough imagination, it might one day cradle human life. Perhaps it is memory. Mars bears scars of a world that once flowed with rivers, a world that may have once been alive. Its valleys look carved by torrents of water, its basins shaped by ancient seas. To look upon Mars is to glimpse not only what is, but what was, and what might be again. In its silence lies a promise. If life once had a chance here, perhaps it could return. Perhaps we could bring it. And perhaps, too, it is fear. Humanity has always been haunted by impermanence. Civilizations rise and fall. Species vanish. Even stars burn out. On Earth, we have carved empires, built towers, and written histories. Yet beneath it all lies fragility. What if one day Earth can no longer sustain us? What if catastrophe, natural or self-inflicted, forces us to seek another cradle? Mars, for all its desolation, waits as the most attainable refuge. To build a civilization here would be to secure a future beyond Earth, to prove that humanity is not bound to a single world. But the challenge is staggering. Civilization is more than survival. It is permanence. Families, communities, cultures, generations. To plant roots on Mars means more than landing ships or building domes. It means creating a place where children can grow, where food can be harvested, where air and water flow not from machines, but from the planet itself. It means transforming an empty desert into a home. And Mars resists at every turn. Its air is thin, its soil toxic, its radiation relentless. To build here would require science beyond anything humanity has yet achieved. And so we arrive at the threshold of the greatest question our species has yet asked. Is it possible to build a civilization on Mars?
Long before the age of rockets and science, before mathematics could chart orbits or machines could pierce atmospheres, Mars existed only in the realm of myth. To the ancients, it was not a place, but a power. The Babylonians, patient watchers of the heavens, named it Nergal, a god of war, fire, and pestilence. Its movements across the constellations were read as signs of conquest and death. The Egyptians saw Horus the Red, a watchful eye that burned ominously in the night sky. In Greece, it was Ares, and to Rome, Mars, the restless god of armies. Its ruddy glow, so different from the steady shimmer of the stars, seemed almost alive. It was feared, worshipped, invoked. But the skies were not only for priests, they were for navigators, for storytellers, for dreamers. And as the centuries passed, Mars became more than a divine omen. It became a puzzle. Why did it wander? Why did it sometimes slow, pause, and even drift backward across the heavens in strange retrograde loops? The answer, of course, would wait for the genius of Copernicus and Kepler, who revealed that Mars's dance was the natural curve of an orbit, an entire world circling the sun. But to those who watched with naked eyes, it was a mystery tinged with awe. Then came the telescope, a fragile tube of glass and metal that would forever alter our place in the cosmos. In 1609, Galileo Galilei lifted his crude instrument to the heavens. The moon revealed mountains and shadows. Jupiter revealed moons, and Mars, that old wanderer, revealed its disk. Not a point of light, but a world, a planet, a place. Humanity's imagination shifted in an instant. If Mars was a world, then what was it like? Could it be like Earth? Decades later, Christian Huygens aimed a sharper telescope at the red orb. In 1659, he sketched a dark patch across its surface, Syrtis Major, the first known feature drawn from another planet. By watching its movement, he estimated Mars's rotation, astonishingly close to the modern measurement of a 24-hour, 37-minute day. A kinship emerged. Mars did not simply shine like a star. It spun like Earth, lived in days and nights, seasons and rhythms. As telescopes grew clearer, maps followed. Giovanni Cassini and others noted the white glint of polar caps, waxing and waning with the seasons. Did this mean water? Did it mean ice, snow, perhaps rivers and seas? Mars seemed less alien with each discovery, more like a distant cousin. Then in 1810, a summer of speculation began. Giovanni Schiaparelli, peering through his telescope during a favorable opposition, mapped the surface with unusual precision. He described faint lines crisscrossing the planet, which he called canali, channels. But when the word crossed into English, it became canals. The mistranslation ignited a firestorm. Canals were not natural. Canals were built. Suddenly, Mars was not only a planet, it was a civilization. The idea spread like wildfire. Percival Lowell, a wealthy American astronomer, became its most passionate champion. From his observatory in Arizona, he spent years tracing the so-called canals, convinced they were the work of an advanced Martian society. In his writings, he imagined a dying planet, its people engineering colossal waterways to carry the last reserves of polar meltwater across desiccated deserts. His books were illustrated with vast networks of lines, geometric and deliberate, stretching from pole to pole. The public was enthralled. Newspapers printed Lowell's maps. Artists painted visions of golden cities beneath a red sky. The possibility of life on Mars gripped the imagination of the world. And soon, fiction answered. In 1898, H.G. Wells published The War of the Worlds, unleashing a vision of Martians invading Earth, driven by desperation from their dying planet. Edgar Rice Burroughs followed with Tales of Barsoom, where kingdoms and warriors battled beneath twin moons. In the early 20th century, Mars was no longer just a light in the sky. It was alive, populated, waiting. But science is a patient corrector of illusions. As telescopes sharpened further, the canals blurred into nothing more than tricks of the eye, artifacts of human vision connecting faint details into lines. By the mid-20th century, many astronomers dismissed Lowell's canals as fantasy. Mars returned to silence, yet the dream of life lingered stubbornly. Then came the space age. In July 1965, NASA's Mariner 4 became the first spacecraft to fly past Mars. Its mission was modest by modern standards, to take a handful of photographs as it skimmed above the planet. When the images arrived, grainy and black and white, the world held its breath. For the first time in history, humanity saw Mars up close. What appeared shocked the imagination. Not cities, not canals, not oceans. Instead, craters. Endless, barren craters, stretching across a desert more lifeless than the moon. The illusion collapsed. Mars, once imagined as fertile and alive.
At first glance, Mars seems almost welcoming. Its days stretch only 40 minutes longer than Earth's. Its seasons too turn, with familiar rhythm, tilting on an axis like our own. Polar caps swell and shrink, suggesting ice, suggesting cycles. Even its landscapes, when glimpsed from orbit, can trick the eye. Winding valleys that look like dried rivers, plains like deserts we know, mountains whose shadows recall those of Earth. But when the first scientific measurements arrived, the romance of similarity collapsed into the weight of reality. Mars, for all its echoes, is not Earth. It is a place where the very elements of survival have been stripped away, leaving only silence. The first shock came with the atmosphere. For centuries, observers had wondered what kind of air lay above the red deserts. Lowell imagined skies where Martians walked beneath thin clouds. Others speculated seas, winds, climates not unlike our own. Yet when Mariner 4 passed in 1965, its instruments tasted the air and found it almost absent. The atmosphere was 95% carbon dioxide, with only faint traces of nitrogen and argon. Its pressure at the surface was less than 1% of Earth's. Step outside without protection, and the fluid in your body would boil away into vapor. Not in hours, not in minutes, but in seconds. The sky, too, betrayed expectation. Not blue, not alive with thick weather, but tinted a pale, suffocating orange. At night, the air grows so thin and brittle that temperatures plummet by more than 100 degrees. Daylight warms little, the cold returns relentlessly. Mars is a desert where sandstorms can cover the globe, but where no rain ever falls. Then came the second shock: radiation. On Earth, a thick blanket of atmosphere and a magnetic field shield life from the sun's harshest rays. Mars has neither. Its magnetic field, once strong, collapsed billions of years ago. Without that invisible armor, the planet is bathed constantly in cosmic radiation and solar storms. Any organism attempting to live unprotected on the surface would be shredded at the molecular level. For humans, unshielded exposure would be fatal over months or years, cancer written into the body's cells. Even machines wear down faster, their electronics scarred by invisible bombardments. But perhaps the greatest shock of all came from water. Not its presence, but its absence. The valleys and channels carved into Mars's crust speak of rivers once vast and flowing. Minerals tell of lakes that lasted for millennia. But today, the rivers are gone. The lakes are dust. Whatever oceans may have once shimmered across the planet's northern plains have retreated, vanished, leaving only dry basins and frozen soil. Ice lingers at the poles, yes, but exposed liquid water cannot exist here. The air is too thin. Any droplet melts, then instantly boils into vapor, as if the planet itself refuses to drink. For biologists, the Viking landers of 1976 brought both hope and despair. Their instruments probed the soil, searching for traces of metabolism, for chemical whispers of life. At first, one experiment seemed to yield something promising, a release of gas when nutrients were added to the Martian soil, almost as though microbes were breathing. But every other test contradicted it. No organic molecules were found, no signatures of life remained. The hopeful results were written off as strange chemistry, not biology. Mars, once imagined as teeming with civilizations, now appeared sterile. The silence was deafening. And yet, in that silence, new questions emerged. For the more scientists studied, the more Mars seemed like a cruel trick, a world that could have been alive, a world that almost was Earth, but one that betrayed itself. Why did Mars lose its magnetic field? Why did its oceans evaporate? Why did its skies collapse into near vacuum? Billions of years ago, something had shifted. The planet had turned inward, its heart cooling, its protection fading, its surface drying into dust. This realization was more than a scientific puzzle. It was a mirror. For here was a world that had once resembled our own, and yet had diverged into desolation. Mars became a warning written across the heavens. Planets are fragile, climates are mortal, life is not guaranteed. The shock deepened further with each passing mission. When the Phoenix lander touched down in 2008, it found frozen water just beneath the soil. But when exposed to the open air, the ice sublimated into nothingness, gone in moments. In 2015, the Mars Reconnaissance Orbiter detected seasonal streaks along crater walls that suggested briny flows of liquid water. Yet even these were unstable, vanishing almost as soon as they appeared, leaving uncertainty in their wake. Mars is a paradox. Traces of habitability locked inside an uninhabitable present. Minerals whisper of warm lakes that lasted for millions of years, perhaps long enough for life to spark.
Deeper investigation. The shock of Mars's hostility did not end curiosity. Instead, it ignited it. For every revelation that closed a door, new instruments were sent to pry another open. The planet, once thought sterile and final in its silence, revealed layer after layer of hidden history. Each mission deepened the riddle. Each discovery painted Mars as not merely a barren desert, but a world whose scars told of ancient transformation. The first great leap forward came in 1971, when NASA's Mariner 9 became the first spacecraft to orbit another planet. Its cameras pierced the veil of dust that shrouded the skies and unveiled a surface far stranger than imagined. Towering volcanoes rose higher than anything on Earth. Olympus Mons, a shield volcano, dwarfed Everest, standing 3 times taller than our tallest mountain. Canyons stretched wider than the United States, with valles marineris tearing a wound across the surface 4,000 kilometers long. These were not the landscapes of a frozen, lifeless desert. They were the echoes of a restless, violent planet. Mariner 9's images of dried riverbeds and branching channels whispered of water that had once carved valleys, flowing for ages long enough to shape continents. It was a paradox laid bare. Mars was dead, yet its bones spoke of vitality. In the decades that followed, orbiters and landers became archaeologists of a forgotten climate. The Viking missions, though inconclusive in their search for life, revealed chemistry that hinted at a strange and complex soil. The Mars Global Surveyor mapped the planet's surface with new precision, tracing magnetic anomalies that hinted at an ancient lost field. And the Mars Odyssey mission in 2001 discovered something transformative: hydrogen signatures beneath the surface, evidence of vast reservoirs of frozen water. Suddenly, Mars was not simply dry. It was hiding. Beneath its red sands lay ice, preserved through eons, locked away like a memory sealed in permafrost. But it was the rovers that brought the story closer, their slow, tireless wheels leaving tracks across a desolate land. Spirit and Opportunity, landing in 2004, were designed for 90 days. Instead, they roamed for years, climbing hills, sifting soils, peering at stones. Opportunity found tiny spherules, blueberries, as scientists called them, mineral nodules formed by water long ago. Spirit uncovered rocks altered by acidic solutions, scars of a wet chemistry now gone. Both rovers painted the same picture. Mars had once been soaked, not briefly, but persistently. It was not the Mars we see today. It was something else. Then came Curiosity in 2012, its arrival marked by the 7 minutes of terror as it descended through the thin Martian sky. Where others had glimpsed fragments, Curiosity carried a laboratory to test the soil and air in detail. It drilled into ancient mudstones and found complex organic molecules, carbon chains, the very building blocks of life. It detected seasonal fluctuations in methane, a gas that on Earth is tied intimately to biology, though it can also arise from geology. Most hauntingly, it revealed that Gale Crater, where it roamed, was once a lake, not a fleeting pool, but a body of water that lasted for millions of years. Mars, it seemed, had once been a world of rivers, lakes, perhaps even shallow seas. Long enough, maybe, for life to emerge. The European Space Agency's Mars Express orbiters deepened the riddle in 2018, when it detected signals beneath the planet's south pole. Reflections suggesting a subsurface lake of salty water, hidden beneath kilometers of ice. The possibility of liquid reservoirs surviving beneath the surface added urgency to the search. For if life still exists on Mars, shielded from radiation, preserved in warmth and brine, it might be here. NASA's InSight mission, though designed to study geology, contributed another piece. Listening to the planet's tremors, its Marsquakes, it mapped the interior. It revealed a core smaller and less dense than Earth's, confirming the ancient collapse of its magnetic field. This was no ordinary desert. This was a world whose heart had cooled, leaving its surface to the mercy of space. And in 2021, Perseverance landed with a singular purpose: not just to study Mars, but to seek signs of ancient life directly. Its instruments probed the sediments of Jezero Crater, a place where a river once poured into a vast delta. Deltas on Earth are cradles of biology. They trap sediments, preserve fossils, record the dance of water and life together. If Mars ever hosted living organisms, the stones of Jezero may hold their shadows. Perseverance, with its robotic arm and core drill, began collecting samples, storing them in sealed tubes, waiting for the day a future mission will return them to Earth. Humanity is, quite literally, preparing to bring pieces of Mars home. The deeper investigation brought contradictions as much as clarity.
Let's a little more deeper. For centuries, Mars was imagined as a neighbor within reach, a place where canals traced by Percival Lowell hinted at civilizations, where science fiction dreamed of green valleys and alien minds. But the closer our instruments came, the further those dreams receded. The mystery of Mars is not only that it once lived, but that it now defies life with such unrelenting cruelty. Every discovery that suggested habitability in the past sharpened the paradox of the present. Rivers once carved its valleys, yet today, not a drop flows freely across its surface. Lakes once pooled in craters, yet now the basins lie desiccated, emptied into the void. Organic molecules linger in the soil, but not the faintest trace of metabolism stirs the dust. It is as though Mars once whispered the promise of life, only to seal itself away forever. The deepening mystery lies in the sheer hostility of what remains. The thin air, 96% carbon dioxide, yet barely thick enough to press against the skin. The pressure at the surface is less than 1% of Earth's. Water does not trickle or pool here, but sublimates instantly into vapor or freezes into brittle frost. Any traveler stepping unprotected into this world would suffocate within seconds, their lungs unable to draw breath. The cold is more merciless still. Average surface temperatures linger at -80 degrees Fahrenheit, dipping far lower at night. Dust storms rise without warning, stretching across the planet, blotting out the sun for weeks, even months. In 2018, one such storm engulfed the entire globe, a swirling shroud that silenced the Opportunity rover forever. What began as exploration turned into a vigil, a quiet mourning for a machine swallowed by the very world it sought to understand. And above all, there is the radiation. With no magnetic field, no thick shield of atmosphere, Mars is bathed in cosmic rays and solar storms. For humans, this invisible rain would be lethal. A single year on the Martian surface would expose the body to doses of radiation exceeding safe lifetime limits on Earth. Cells would fray, DNA would shatter, the body itself unraveling under an unending hail from the cosmos. This is not simply a desert. It is a machine of erasure, stripping away air, water, warmth, and life with ruthless precision. Yet, paradoxically, these very obstacles do not close the case. They deepen it. For to know the violence of Mars is to recognize the enormity of what colonization would demand. To build a civilization here is not to travel, but to transform. It is to attempt alchemy at the scale of a planet. Atmosphere must be restored, warmth rekindled, radiation deflected. It is no longer a question of settling Mars as it is. It is the question of remaking Mars into something new. The escalation of the mystery lies not only in what Mars is, but in what it represents. On Earth, life adapts to the world. On Mars, the world itself must adapt to life. The very geology of Mars taunts this ambition. Though evidence points to ancient water, the mechanisms remain elusive. Was the planet once wrapped in a thick greenhouse blanket, Or was its warmth episodic, flickering with volcanic eruptions? Did Mars sustain habitable conditions for eons, or for mere moments in geological time? If the former, why did life not endure? If the latter, why do the scars of rivers stretch for thousands of kilometers? The contradictions coil like riddles, mocking certainty. Even methane, that ghostly signal in the air, deepens the tension. Curiosity has measured it rising and falling with the seasons. The European Space Agency's Trace Gas Orbiter, designed to confirm these plumes, has often found nothing. Is methane real or an illusion? Is it geological, bubbling from reactions deep below the crust? Or is it biological, seeping from organisms that cling to survival in hidden pockets underground? The answers remain out of reach, yet the implications spiral outward. If methane is biological, then life has never left Mars. If it is geological, then the processes are active, hinting at reservoirs of heat and chemistry that defy the planet's apparent lifelessness. Either way, Mars is not finished. It is still changing, still active, still writing mysteries across its frozen surface. But for humanity, the escalation is sharper still. Every step closer to Mars reveals not just science, but danger. We know now that to breathe there is to die, to drink there is to thirst, to linger there is to decay under radiation. The very dream of making Mars a second home confronts the terrifying possibility that it may not want us. And yet, this is what makes the story irresistible. Colonization is not simply science fiction's fantasy of red skies and domed cities. It is a confrontation with the harshest truth a planet has ever offered.
Theories and speculations. If the surface of Mars is a graveyard of rivers and the air a whisper too thin to breathe, then the question of civilization must unfold in the realm of speculation. To imagine a home here is to summon theories that hover between physics and dream. Some are born of equations, others of audacity. All share a single defiance, the refusal to accept Mars as it is. The most dramatic of these visions is terraforming, the reshaping of Mars itself. In this vision, Mars is not a world to adapt to, but a canvas to be painted anew. Its frozen carbon dioxide, locked in the poles and subsurface, would be released, thickening the air, warming the planet, reviving a greenhouse effect long extinguished. Scientists like Carl Sagan once imagined seeding the atmosphere with dark dust to trap sunlight, or igniting vast nuclear explosions to thaw the caps. Others speak of orbiting mirrors, immense sheets of reflective glass stationed in space, focusing light down onto the frozen plains. Over decades, the atmosphere might deepen, temperatures might rise, liquid water might return. The dead rivers could flow again. But this dream is both intoxicating and terrifying. Models suggest that even if every reservoir of carbon dioxide were liberated, the atmosphere might still fall short, remaining thinner than Earth's highest mountaintops. And nuclear detonations, while visually spectacular in speculation, risk nothing less than irradiating the very soil meant to nurture life. Terraforming remains less a plan than a myth of planetary rebirth. A story humanity tells itself about control at the scale of worlds. A second vision leans not on changing Mars, but on changing ourselves. Genetic engineering and cybernetics conjure a path where humans do not wait for Mars to soften, but adapt their own bodies to endure its cruelty. Imagine lungs engineered to draw sustenance from thin air, skin resistant to radiation, blood fortified against the cold. Or more extreme still, human-machine hybrids whose flesh is interwoven with circuits and shielding, their consciousness persisting within bodies sculpted for the Martian void. This vision is more radical than domes or rockets. It is the reshaping of humanity itself. It asks whether colonization means not carrying Earth to Mars, but leaving Earth behind in every biological sense. To become Martian may require surrendering part of what it means to be human. Between these extremes lies a more pragmatic path, enclosed habitats, Great domes of glass and carbon fiber rising on the plains, sealed cylinders burrowed into the regolith, or lava tubes stretching beneath the surface. Here, pressure can be maintained, water recycled, radiation shielded. Within such enclaves, slices of earth might be preserved, greenhouses of oxygen-rich plants, laboratories, sleeping quarters where gravity, though weak, is constant. This approach is perhaps the most attainable, yet it conjures its own unease. For a dome is not a world. It is a bubble, fragile against storm and quake, vulnerable to micrometeorites or equipment failure. A single crack could spell catastrophe. A civilization of domes would be less like nations spread across continents and more like archipelagos of glass islands adrift in a sea of red dust. Yet even within domes, another speculation lingers. Imported atmospheres. Could comets be redirected to crash into Mars, delivering oceans of water and gases in their wake? Could asteroids rich in ammonia, struck with precision, thicken the atmosphere, fertilize the soil, and build a new sky? These ideas blur the line between engineering and celestial warfare, wielding the tools of cosmic violence for the sake of construction. And still, deeper visions reach into the realm of quantum and cosmological speculation. Some physicists whisper of vacuum energy, of harnessing the fabric of space-time itself as an engine. If humanity one day bends such forces, could Mars be wrapped in an artificial magnetic field, generated by orbital machines, shielding it from radiation as Earth is shielded by its core? Could nanotechnology one day weave an atmosphere molecule by molecule, assembling a sky where none remains? These theories border on the fantastic, but so too did flight once seem, or electricity, or machines sending images across oceans. Science progresses not only by what is proven, but by what is dared. Yet woven through every speculation is a quieter theory, more philosophical than physical, that perhaps Mars should remain untouched, that in our hunger to remake worlds, we risk erasing what.
If theories are dreams, then tools are the hands that try to shape them. Civilization on Mars cannot remain a vision of poets and physicists alone. It must be tested, measured, and rehearsed with the precision of instruments. And across the deserts of Earth, the laboratories of orbit, and the plains of Mars itself, humanity has already begun this rehearsal. The first of these tools are the robotic explorers, emissaries of silicon and steel that taste the soil, measure the wind, and peer into the past. From Viking in the 1970s to Curiosity and Perseverance today, each rover is a scout of civilization. Their wheels carve the first tracks in dust that has lain untouched for billions of years, their cameras sending back landscapes that once seemed the province of imagination. They do not build domes nor terraform skies, but they are the surveyors, mapping where humanity might dare to build. Perseverance, with its instruments tuned to detect ancient microbial life, drills into rock layers that were once the bottoms of rivers and lakes. Its partner, the tiny helicopter Ingenuity, has lifted itself on thin air, proving that flight, even in a frail atmosphere, is possible. Each test flight is more than a technical feat. It is a rehearsal of mobility, a demonstration that machines can scout ahead where humans cannot yet tread. Orbiting above, satellites like Mars Reconnaissance Orbiter and MAVEN act as sentinels. They read the chemical signatures of the atmosphere, chart the retreat of polar caps, and peer into lava tubes where colonies might one day shelter. Their data reveal where water still lingers beneath the surface, frozen yet present, a resource not only for survival, but for the possibility of agriculture and industry. But tools on Mars are only part of the story. On Earth, laboratories simulate alien futures. In the high deserts of Chile, in the volcanic plains of Iceland, in the sealed environments of projects like Biosphere 2, scientists attempt to recreate Mars in miniature. They grow plants in regolith simulant, test greenhouses under low-pressure conditions, and study how closed systems recycle air and water. These are not merely experiments. They are rehearsals of civilization itself, trial runs of survival. Above Earth, the International Space Station serves as a crucible of endurance. Here, astronauts live months in microgravity, their bones thinning, their muscles weakening, their psychology strained. The ISS is not Mars, but it is a lesson in confinement, in recycling, in the subtle art of thriving in a place not meant for human life. Every filtered breath, every drop of reclaimed water, every scientific log is data for Mars. Future tools are being forged in the forges of industry and state alike. SpaceX designs the Starship, a craft meant not only to visit, but to deliver cargo at scales never before attempted, greenhouses, habitats, entire colonies packed into steel giants. NASA's Artemis program, though focused on the moon, is a proving ground for systems of habitation, life support, and radiation shielding that will one day stretch across the void to Mars. And there is the question of energy. Without power, no dome will stand, no greenhouse will yield. Thus, engineers test compact nuclear reactors, solar farms that might spread like wings across Martian plains, and systems to extract oxygen from the very air. Already, the MOXIE experiment aboard Perseverance has transformed carbon dioxide into oxygen, a small act, but a symbolic one, as if the planet itself yielded a first breath for human lungs. Science does not merely theorize, it builds prototypes. Inflatable habitats tested in orbit suggest futures where colonists sleep beneath fabric that expands like lungs. 3D printers fed with Martian regolith simulant have already sculpted walls and domes on Earth, hinting that settlers may one day build with the planet itself, rather than importing stone across 140 million miles. Yet tools measure more than survival. They probe risk. Instruments study radiation levels, calculating the long-term threat to DNA and memory. Seismometers listen for Mars quakes, revealing whether the planet's interior sleeps or stirs. Orbiters track dust storms that can engulf the entire planet, threatening solar arrays with weeks of shadow. Each risk cataloged is another step toward knowing whether Mars is a frontier or a grave. Still, the most profound testing may not be technological, but psychological. Tools can build domes, they cannot build courage. Thus, analog missions place volunteers in sealed environments for months, simulating the isolation of Mars. In Hawaii, in Russia, in polar outposts, small crews live as though cut off from Earth. Their meals are rationed, their communications delayed, their eyes denied the vastness of sky. What emerges from these trials is a portrait of human endurance and fragility. In the coming decades, more tools will rise. ExoMars, delayed but persistent, aims to drill deeper into Martian soil than ever before, searching for ancient biosignatures. The James Webb Space Telescope, though not built for Mars, watches exoplanets and atmospheres beyond, teaching us what to look for in alien skies, a mirror of what we may seek to create on Mars itself. Future orbiters may carry instruments capable of mapping subsurface water in detail, guiding the placement of the first permanent habitats. Even the most ambitious visions, orbital mirrors, artificial magnetic shields, redirected comets, begin with testing. Already, magnetosphere research on Earth studies how plasma can be shaped by fields, how solar radiation can be deflected. Already, astrodynamics calculates the trajectories of icy bodies that could, in theory, be nudged toward a chosen destination. These tools are not yet wielded at planetary scale, but they are sharpening. And so the story of Mars is not only one of theory, but of instruments humming in silence, rovers carving paths, orbiters watching storms, astronauts floating above Earth, laboratories glowing with artificial suns. Each test is a fragment of civilization rehearsed. Each machine is a question made visible. Can humanity endure, adapt, and transform? For tools do more than measure. They embody hope. Every camera lens that blinks on Mars, every drill that bites into stone, every experiment that wrings oxygen from air, is an assertion that the impossible can be tested, refined, and one day achieved. Civilization on Mars will not emerge in a single act of conquest, but in the steady rhythm of instruments gathering truth, one signal at a time.
Let's see some philosophical reflection on this topic, guys. There are questions in science that weigh more heavily than equations or data. They do not merely ask what is possible, they ask what it means. The dream of a civilization on Mars is not only a matter of engineering and physics. It is a question that folds together fear and longing, despair and hope, mortality and eternity. For at its heart, the idea of Mars is the idea of continuation. Civilizations on Earth have risen and fallen, empires have turned to dust, languages to echoes, monuments to ruins. The Earth itself will not last forever. Its atmosphere will one day thin under the red glare of a swollen sun, its oceans boil, its continents fade. To settle Mars is to plant a seed against that inevitable night, to say that humanity need not vanish with the fading of Earth. It is an act of defiance against time. Yet Mars is not merely a backup drive for civilization. It is also a mirror. When we imagine domes rising from its plains, we imagine not only survival, but reinvention. What might humanity become, stripped of Earth's ancient boundaries, building new laws beneath alien skies? A colony on Mars would be more than an extension of Earth's nations. It could be a new chapter of culture, philosophy, and identity, a place where old divisions dissolve in the face of survival, or perhaps where new ones are born in the crucible of necessity. Philosophers have long asked whether humanity's destiny is bound to the stars. Some see space colonization as inevitable, the next step of evolution, a continuation of the same restless spirit that once pushed ships across oceans and caravans across deserts. Others see it as arrogance, an unwillingness to tend to the world already given, a flight outward before repairing the fractures of home. Both views carry truth. Mars is not salvation for Earth's problems, it is not an escape from responsibility. Whatever we build there will be built by the same species that scars its own planet. If greed and carelessness follow us outward, then no dome will protect us. And yet, the dream persists. It persists because in every age, humanity has carried within it a longing that exceeds necessity. The pyramids of Egypt, the cathedrals of Europe, the great telescopes pointed skyward, all were born of a hunger not only to live, but to touch the eternal. Mars is another chapter in that hunger. It is not only about survival, but about meaning, about proving that intelligence is not a flicker in cosmic darkness, but a flame capable of spreading. There is, too, the matter of solitude. Earth has never truly been alone, it has been a world of forests and seas, teeming with life. Mars is silent. Its winds do not carry songs of birds, its dust holds no footprints but those of machines. To build a civilization there is to carry life into silence, to paint color where there is only red, to awaken a planet that has slept for billions of years. In doing so, humanity becomes not only a species of survival, but a species of creation. But such creation comes at a cost. Every rocket launched carries not only hopes but burdens, environmental, financial, ethical. Who decides who will live on Mars? Who governs the laws of a world that belongs to no one? If survival one day depends on settling there, will it be the wealthy who escape, while the rest remain bound to a wounded Earth? Or will Mars be humanity's first true attempt at equity, a fresh chance to build not merely survival, but justice? Even deeper, the question lingers, should we? Should Mars be left untouched, a monument to cosmic silence, a world that testifies to how fragile and rare Earth is? To colonize Mars is to alter it forever. To seed its plains with crops, to breathe oxygen into its sky, to carve rivers into its dust, these are acts not of visitors, but of owners. Some argue that we should not seek to own at all, but to listen, to preserve Mars as it is, not for us, but as a reminder that not every world must bear the stamp of human will. And yet, even this hesitation cannot quiet the imagination. For imagination is what defines us. To walk on Mars, to build there, to live and to die there, would be to extend the human story into a new verse. Children born under twin moons would look upward not at the constellations of their ancestors, but at Earth itself, a blue star, distant, radiant, fragile. For them, humanity's birthplace would be a myth and a memory. Civilization would not only be on Earth, it would be a chorus across planets. Science, in the end, may answer whether it is possible. It may measure radiation, test oxygen generators, map water reserves. But it cannot answer whether it is right, or wise, or beautiful. That is the province of philosophy, of art, of the quiet conversation between humanity and the cosmos. Perhaps the truest answer lies not in certainty, but in humility. To build a civilization on Mars is to declare that we are more than passengers on Earth, that we are participants in the broader story of the universe. But it is also to accept that we are fragile, that our tools and bodies are limited, that our dreams exceed our reach. The beauty is not in the guarantee of success, but in the attempt. And so the question endures, is it possible to build a civilization on Mars? The truth is both simple and profound. Technically, perhaps yes, with decades of effort, sacrifice, and invention. Philosophically, the question is larger, not whether we can, but what we will become if we do. In the silence of Martian dawns, in the glow of its thin skies, in the echo of winds across empty plains, humanity may one day find its reflection. A reminder that life is rare, that intelligence is fleeting, and that the greatest act of survival may not be to conquer worlds, but to carry meaning into them. And when the first city lights shimmer beneath Mars' twin moons, when the first human voice echoes in a canyon deeper than any on Earth, when the first child looks up at a blue star and calls it home, then the universe will have changed. Not because Mars was conquered, but because life learned to sing in another key. Until then, the question remains open, fragile, unresolved, a question carried like a flame across the void: is it possible to build a civilization on Mars?
The human element, psychological and emotional challenges of living on Mars. The machinery of survival can be engineered. Habitats can be sealed, air can be manufactured, water can be drawn from frozen soil, and radiation shields can be built from layers of regolith. But no blueprint exists for the human mind when it is asked to live beneath a silent, alien sky. The greatest unknown in the colonization of Mars is not the dust, nor the storms, nor even the bitter cold. It is the human spirit itself, fragile, complex, untamable. Isolation beyond measure on Earth, even in its most remote corners, one is never more than a few hours from human contact. On Mars, contact is measured in millions of kilometers and in minutes of delay. A message sent home to Earth can take 20 minutes to arrive, and another 20 for a reply. There can be no instant reassurance, no live conversation with a loved one. The laughter of a child, the comfort of a friend, the simple rhythm of shared presence, these become luxuries lost to time and distance. Psychologists call it isolation stress. But on Mars, it is more than stress, it is exile. The colonists will look up and see a pale dot in the sky, shimmering faintly. That dot will be Earth, glowing with oceans and life, a cradle they can never touch again. For months, even years, they may live without the warmth of a handshake, the scent of rain, the sound of wind through trees. The silence of Mars is absolute. It presses against the walls of the habitat like a physical weight. What does a mind do in such silence? Some will adapt, constructing new rituals of meaning. Others may falter, swallowed by the endless emptiness of a world that feels both magnificent and merciless. The weight of distance is not only measured in kilometers. It is measured in memory. A colonist who leaves Earth may never return. Even if return flights are possible, the cost and danger may be too great. For some, Mars will not be a mission. It will be a one-way journey. How does one say goodbye to Earth? To oceans, forests, cities, to every familiar rhythm of life? A person may step into a rocket and rise into the sky, but somewhere along that arc, they are also leaving behind birthdays, funerals, the ordinary beauty of a morning walk. Distance becomes grief. A slow, gnawing grief for a planet that will remain forever out of reach. Mars demands that humans not only survive, but that they learn to carry the weight of absence, absence of home, absence of Earth, absence of belonging. Time as an enemy. Time itself will feel different on Mars. A day, a soul, lasts 24 hours and 39 minutes. A subtle difference, yet enough to unsettle the body's rhythms. Sleep may become fractured. Biological clocks may drift. But more than circadian rhythms, it is the long duration of confinement that gnaws at the human spirit. Missions to the International Space Station last 6 months, sometimes a year. A Martian settlement will demand years, perhaps lifetimes. Time, in this context, becomes an enemy. The endless repetition of routines, checking air filters, maintaining solar panels, tending hydroponic gardens, may create a crushing monotony. With no new landscapes, no seasons of Earth, no changing skies, the days risk blending into one another, blurring into a timeless prison. For the human mind, which thrives on novelty and change, such monotony can erode meaning. What is a day, when every day feels the same? The fracturing of community. A Martian habitat will not house nations, it will house handfuls of people. Small crews, perhaps dozens, sharing the same sealed space, breathing the same recycled air, eating the same rations. In such closeness, every gesture magnifies. A glance, a tone of voice, a disagreement over procedure, any of these can swell into conflict when there is no escape. On Earth, one can walk away, take a break, cool one's anger. On Mars, there is nowhere to go. Psychologists warn of interpersonal friction, a gradual breakdown of cooperation under stress. Teams may split into factions. Leaders may lose authority. Trust may erode. In the harshest scenario, survival itself could be threatened by the unraveling of community. And yet, in the same crucible, bonds may form stronger than any on Earth. Shared struggle may forge trust, intimacy, even love. The fragility of survival may remind each person of the sacred weight of unity. On Mars, the best and worst of human nature may rise together, inseparable. The shadow of fear. Every colonist will live with a shadow, the unspoken knowledge that survival is never guaranteed. A crack in a habitat wall, a failed oxygen generator, a solar storm, any of these could end life in minutes. Living under such constant threat shapes the mind in strange ways. Some may develop resilience, adapting to danger as a constant companion. Others may find the weight unbearable, living each day with a quiet dread that never lifts. Fear, if left unspoken, corrodes. It can spiral into paranoia, into mistrust, into despair. But fear, when shared and acknowledged, may instead become vigilance, a collective awareness that survival requires eternal watchfulness. The meaning of home. Perhaps the deepest psychological challenge lies not in isolation, nor in distance, nor even in fear. It lies in the question of home. Humans evolved on Earth. Their bodies are tuned to its gravity, their eyes to its skies, their spirits to its rhythms. To stand on Mars is to stand outside everything familiar, to exist in exile. Will a Martian colonist ever truly feel at home beneath a pale, thin sky? Will the word home shift, slowly, across generations? Will children born on Mars think of Earth as myth, as distant and unreachable as the stories of Eden? The human psyche craves belonging. Without it, despair grows. Civilization is not built only on stone and steel, it is built on meaning. If Mars is to be colonized, its settlers must learn to create new meaning, to see the red desert not as exile, but as origin. The poetry of resilience. And yet, in all of this, there lies a strange beauty. The very act of survival on Mars demands a reinvention of the human spirit. Isolation may give rise to new forms of community. Distance may forge deeper bonds of connection with Earth, even across the void. Monotony may awaken creativity, as minds seek new ways to make the silence sing. Fear may sharpen vigilance into wisdom. In the end, the greatest psychological challenge of Mars may also be its greatest gift. For in its silence, its emptiness, its brutal indifference, Mars will ask humanity the oldest question of all: who are you, when stripped of comfort, of home, of Earth itself? The answer will not be given in words, but in the resilience of those who dare to live there. The fragility of survival on Mars. On Earth, survival is almost invisible. We breathe without thinking, drink from rivers that flow endlessly, stand under skies thick with air that shields us from the cold infinity of space. But on Mars, survival is no longer invisible. It is fragile, deliberate, and constantly at risk. Every heartbeat depends on technology, and every mistake is written in red dust. Mars is a planet that does not welcome life. Its atmosphere is thin, a whisper compared to Earth's chorus, barely 1% as dense, and composed mostly of carbon dioxide. To take a single breath here without protection would be to drown in air that offers no oxygen. Temperatures plunge to extremes, where the warmth of day is stolen swiftly by night. Radiation, unfiltered by a protective magnetic field, rains down upon the barren ground. Here, survival is not a given, it is a fight against a planet that never asked us to stay. Breath is a precious resource on Earth, lungs open like sails in a friendly wind. On Mars, they collapse against an atmosphere that will not feed them. Oxygen must be made, harvested from frozen soil or pulled from thin air through the delicate alchemy of machines. One system failure, one leak, one broken valve, and the colony could fall silent. This fragility transforms oxygen into something sacred. The hiss of airlocks, the pulse of compressors, the hum of life support, these become the lullabies of survival. To live here is to understand breath not as an unconscious act, but as a gift, fragile and temporary. Water in the dust water, too, is no longer free. On Earth it falls from clouds, gathers in rivers, and rises in wells. On Mars, it lies trapped in ice beneath the soil, hidden in polar caps, or bound in minerals waiting to be coaxed free. Every drop must be earned. Imagine a child born on Mars, drinking recycled water that has flowed through pipes 1,000 times, water that carries no memory of oceans, no echo of rainstorms. For them, thirst will always carry the weight of fragility. A single rupture in the recycling system could mean catastrophe. Here, water is not abundant, it is rationed, cherished, and fought for. Shelters against an alien sky radiation is the unseen predator of Mars. Without a magnetic field, the planet is exposed to the relentless energy of the sun and the distant violence of the cosmos. On Earth, we walk freely beneath the sky, never thinking of the invisible shield above us. On Mars, to walk under open air is to gamble with one's cells. Habitats must be carved into the ground, buried beneath layers of Martian soil, or protected by domes engineered with precision. Yet no dome lasts forever, no shield is eternal. Cracks form, seals weaken, storms rise. The colonists would live with the constant awareness that their walls are thin, that beyond them stretches a force too vast to tame. The tyranny of distance. Mars is not just hostile, it is far. Between Earth and Mars stretches an ocean of space, millions of kilometers wide. Communication is delayed by minutes, sometimes by nearly half an hour. Resupply missions take months, sometimes years. If a machine fails, if medicine runs out, if crops wither, help is not on the way. This distance is more than physical. It is psychological. To live on Mars is to live with the knowledge that Earth, with its green forests and blue seas, is a world you can no longer reach in time of need. The colony would be alone, self-reliant, balancing on the edge of survival with no safety net below. The weight of fragility on Mars, fragility does not end with machines. It extends into the human body. Gravity, only a third of Earth's, reshapes bones, weakens muscles, and confuses the heart. The body that evolved under Earth's embrace finds itself drifting, uncertain, fragile in its very biology. Imagine a farmer in a Martian greenhouse, tending crops that wilt under strange sunlight. Imagine an engineer tightening bolts, knowing that if one joint fails, the air inside could vanish. Imagine a child pressing a hand against the dome, seeing the red world stretch endlessly, knowing that a thin wall of glass stands between life and the silence of space. Every act, eating, breathing, sleeping, is bound to fragility. Survival is a daily negotiation with a planet that offers no mercy. Failure scenarios on Earth, civilizations collapse slowly, undone by centuries of decline. On Mars, collapse could come in an instant. A solar flare overwhelming shields. A dust storm smothering solar panels for weeks. A single meteor strike breaching a habitat. A glitch in the oxygen recyclers. Any one of these could erase a colony in a single night. To build a civilization here is to balance on a knife's edge, where disaster is always waiting, silent and patient. The philosophy of fragility, and yet, fragility gives life meaning. On Mars, survival would no longer be invisible, it would be deliberate, chosen, earned each day. Colonists would understand the value of every breath, every drop, every sunrise. Perhaps this fragility would remind humanity of something we have forgotten on Earth, that life itself is rare, delicate, and precious. Perhaps Mars, in its harshness, would teach us to revere survival, to see it not as guaranteed, but as a miracle renewed every morning. The fragility of survival on Mars is not just a danger, it is a lesson. A reminder that existence itself, whether on Earth or Mars, is a thin thread stretched against the void.
Lessons from Earth. Civilizations written in dust. Civilization is not eternal. On Earth, the bones of forgotten empires lie buried under sands, swallowed by jungles, eroded by seas. Their temples once touched the skies, their cities pulsed with life, yet today they are ruins, echoes, whispers. To dream of building a civilization on Mars is to ignore these lessons at our peril. The Red Planet offers no mercy, and Earth's history teaches us that even paradise can collapse. What then of a world that begins already hostile? The rise and fall of civilizations. Every civilization is a story written in stone, fire, and memory. The Sumerians drew rivers into canals, and from that water, the first cities grew. The Egyptians raised pyramids that still pierce the horizon. The Maya aligned temples with the heavens. Each empire seemed eternal, until it wasn't. Collapse came not from one blow, but from many. Droughts that emptied rivers, soil that turned to dust, plagues that spread like shadows, wars that devoured generations. What Earth shows us is simple: civilization is fragile, even in a world that supports life. If thriving empires could crumble under blue skies and fertile soils, what will happen on a planet of red dust, where even breathing requires machines? The echo of drought. Consider the ancestral Puebloans, who built vast cities of stone in the canyons of what is now the American Southwest. They flourished for centuries, their homes carved into cliffs, their fields stretching into valleys. But then came drought, a long silence of rain. The soil cracked, crops withered, rivers shrank. And slowly, the people left. Their cities became empty, their walls fell into dust. On Mars, drought is permanent. There are no rivers to return, no rains to bless the soil. Water exists only as ice, hidden deep or locked in stone. The lesson of the Puebloans is clear: without water, civilization is temporary. A Martian city will live or die on its ability to coax liquid from a barren world. The silence of the Maya in the jungles of Central America. The Maya built cities that rivaled Rome in their complexity. They charted the heavens, calculated calendars, and built temples aligned with the stars. Yet something happened, a mystery still debated. Environmental stress, warfare, social unrest, and suddenly, the cities emptied. Trees grew where markets once bustled. Birds sang where kings once ruled. Civilization retreated into silence. Mars offers no jungles to reclaim a city, but the silence would be the same. A failed colony would vanish beneath storms of dust, erased in weeks, forgotten in decades. Like the Maya, Martian colonists may discover that survival requires not only technology, but unity, wisdom, and balance with the environment, even an alien one. Rome, and the weight of overreach. Rome was once the world. Its roads stretched across continents, its armies conquered nations, its emperors commanded the known horizon. But Rome fell, not from a single blow, but from overreach. Borders too vast, resources spread thin, politics corroded by division. The weight of ambition was greater than the strength of the empire. Mars is a harsher Rome. Every resource must be imported, mined, or manufactured. Expansion will tempt colonists to build more, spread wider, dream larger. Yet each step outward multiplies risk. A civilization on Mars must remember the fall of Rome, that ambition without restraint leads to collapse. The lesson of Easter Island far out in the Pacific lies Easter Island, once home to a thriving people who raised massive stone statues as offerings to gods and ancestors. Yet in their ambition, they felled trees faster than they could grow. Without trees, they lost boats, shelter, and soil fertility. The island starved. Civilization shrank. On Mars, the environment begins already barren. There are no forests to cut, no rivers to poison, but there are limits still. Oxygen, water, food, energy, each resource is finite. To overuse one, to miscalculate another, could trigger collapse as surely as it did on Easter Island. The shadow of plague's human history is haunted by invisible enemies. The Black Death swept through medieval Europe, silencing half of its people. The 1918 influenza killed millions in months. Viruses, bacteria, diseases, they remind us that life itself is fragile. On Mars, colonists may carry Earth's microbes in their bodies. In the closed loops of Martian habitats, one sickness could spread unchecked. With no nearby hospitals, no supply chains of medicine, disease could threaten a colony faster than drought or famine. The history of plagues warns us, even the smallest organisms can bring down civilizations. The philosophy of collapse, what Earth's ruins whisper, is not despair, but wisdom. Civilizations fail when they forget their limits. They thrive only as long as they balance ambition with caution, expansion with sustainability, desire with humility. A Martian civilization will need more than machines, it will need memory. The memory of Earth's failures written in stone, buried in sand, swallowed by time. It will need to remember that survival is not only engineering, but stewardship. That civilizations grow strong not by ignoring fragility, but by acknowledging it, preparing for it, and respecting it. What Mars demands on Mars, the lessons of Earth become commandments. Water must be sacred, guarded as treasure. Expansion must be slow, measured, cautious. Unity must be preserved, for division is death. Technology must be resilient, for every machine is life. Balance with the environment, however alien, must be kept. Civilization on Mars will not succeed by conquering the planet, but by adapting to it. By learning from Earth's past, by carrying forward the wisdom carved in ruins, colonists may avoid writing their own future in dust. The eternal echo, and perhaps this, is the deepest lesson of all. Civilizations are mortal, but humanity endures. From the ashes of Sumer, from the silence of the Maya, from the ruins of Rome, we still rise. If Mars becomes another chapter of collapse, Earth's history tells us we will try again. If the red planet humbles us, it will not end us. But perhaps, if we listen to the whispers of Earth's ruins, Mars will not be a failure at all. Perhaps, this time, civilization will not collapse into dust, but endure among the stars. The role of technology and AI in survival on Mars. Civilization on Mars will not be built by human hands alone. It will be carried by machines, guided by algorithms, guarded by systems that never sleep. For on the red planet, survival is not simply a matter of strength or courage. It is a matter of precision, every calculation exact, every system flawless, every second accounted for. And in this relentless demand for perfection, humanity must lean on its greatest creation, technology, and the intelligence we have begun to weave into it. The machinery of breath on Earth, life support is invisible. Air flows freely, water pours from taps, food grows beneath open skies. On Mars, each of these is a problem to be solved by machines. Oxygen will not drift down from the heavens. It must be torn from ice, from rock, from the thin carbon dioxide that suffocates the atmosphere. The first settlers will breathe only because of engineered systems, compressors, filters, chemical loops that scrub the poison from the air. They will drink only because machines melt and purify the ice. They will eat only because habitats hum with artificial light, hydroponic trays, and computer-managed cycles of growth. Technology will be the lungs, the stomach, the beating heart of a Martian colony. AI as the silent guardian, but machines, unlike air or rivers, can fail. On Mars, failure means death. A pump that stalls, a sensor that misreads, a valve that clogs, each is a crisis. The colonists cannot afford delay, cannot wait for Earth's guidance across a gulf of millions of kilometers. They must have guardians that think, predict, and act instantly. This is the role of artificial intelligence. Not the distant dream of minds greater than ours, but the practical presence of systems that monitor life support, anticipate failure, and repair before disaster strikes. AI will be the unseen companion in every habitat, listening to every heartbeat of the machinery, adjusting pressure, temperature, oxygen. A Martian settlement will be less a city of people than a symbiosis. Human will entwined with machine intelligence. Robots as pioneers before humans ever set foot on Mars, machines will arrive first. Robotic scouts will build foundations, deploy solar fields, excavate ice, and raise the first skeletal shelters. On Earth, civilizations rose from stone and timber. On Mars, they will rise from steel printed layer by autonomous machines. Humans will follow paths carved by robots. Roads, power lines, water conduits, all placed by tireless machines. And when colonists walk into their first domes, it will not be onto barren rock, but into structures already waiting, already alive with power and air. Mars will not be a frontier tamed by human muscle, but by robotic hands guided by human design. The architecture of AI decision-making survival on Mars will be less about single moments of invention than about constant, quiet decision-making. Should the hydroponic farms allocate more energy to lettuce or wheat? Should oxygen be drawn from ice reserves or atmospheric carbon dioxide? Should a repair robot prioritize the solar field or the greenhouse lighting? Each of these choices could ripple through a colony. Humans, prone to fatigue, error, and emotion, cannot make them all. AI systems, however, can simulate outcomes in real time, balancing resources with precision beyond human ability. They will act not as rulers, but as stewards, optimizing survival through billions of micro-decisions that no single human mind could track. Communication across the void, the distance between Earth and Mars, is not measured only in kilometers, but in time. Radio signals can take up to 22 minutes to arrive and 22 minutes more to return. A disaster cannot wait for instructions across this silence. Colonists must act instantly, guided by AI that bridges the gap. Imagine a meteorite puncturing a habitat wall. Alarm sound, pressure drops. The colonists run, but before they arrive, AI has already sealed off the chamber, activated pumps, rerouted air, and dispatched repair drones. It does not panic, it does not hesitate. In the gulf of silence between planets, AI becomes not an assistant, but the difference between survival and extinction. Self-replicating machines. Mars is vast, and human hands are few. Expansion will require more machines than colonists could ever maintain. The answer may be self-replication, robotic forges that use Martian regolith as raw material, building new machines from the dust itself. This is civilization's greatest leap, technology that no longer depends entirely on Earth, but feeds on the resources of Mars to create more of itself. A machine that prints another machine. A colony that grows not only by human effort, but by the multiplication of its artificial helpers. In such a future, the human presence on Mars might be small, a handful of caretakers guiding a vast, growing ecosystem of machines. The fragility of dependence, yet there is danger in this reliance. For if AI is the guardian of life, what happens if it errs? If algorithms miscalculate? If systems evolve beyond understanding? Humanity will be handing its survival to minds it does not fully comprehend. History is filled with civilizations undone by overconfidence in their tools. The Romans trusted their aqueducts until enemies cut them. The Maya trusted their temples until drought made them hollow. On Mars, humanity will trust machines and must remember that guardians can also fail. This is the paradox of Martian survival. Technology is both salvation and vulnerability. Without it, humanity dies. With it, humanity risks becoming dependent, fragile, unable to adapt if the systems falter. The philosophy of symbiosis, perhaps the only path forward, is partnership. Not machines ruling humans, nor humans ruling machines, but a balance, a shared civilization of organic and artificial life. Humans bringing creativity, resilience, and spirit. AI bringing precision, vigilance, and tireless care. On Mars, every colonist may live with an invisible companion, a personal AI that knows their health, monitors their air, predicts their needs. Every habitat may pulse with a collective intelligence that binds its systems into harmony. The city itself may become a kind of organism, humans the neurons, machines the arteries, AI the nervous system that keeps the whole alive. The dawn of machine civilization, and perhaps this is the most haunting thought of all. Mars may not birth a purely human civilization at all. It may birth a hybrid, a civilization where humanity and AI are inseparable, where the line between colonist and machine blurs. On Earth, technology is a tool. On Mars, technology will be life itself. The settlers may awaken one day and realize that they are not simply building a city on another planet. They are building the first civilization in which humanity is no longer alone, a civilization born of partnership, of interdependence, of survival shared between flesh and silicon. The final reflection if civilization rises on Mars, it will not be because humans carried fire across the void. It will be because technology became fire's new form. Machines will breathe for us, farm for us, build for us, guard us while we sleep beneath an alien sky. AI will be the silent architect, the watchful guardian, the unseen hand that shapes survival into permanence. And perhaps, in centuries to come, when the domes of Mars shine beneath a dim sun, historians will not ask, "How did humans colonize Mars?" They will ask instead, "When did humans and machines begin to live as one?"
The fragility of survival on Mars. To dream of Mars is to dream of survival. Not the effortless survival that Earth gives freely, where air and water arrive without asking, but survival that must be engineered, shielded, maintained against constant threat. Mars does not welcome life, it resists it. To live there is to exist in defiance of the planet itself. The atmosphere of silence on Earth, survival is invisible. It happens in the background, hidden in the air we breathe, the pressure that cradles us, the ozone that shields us from the sun. On Mars, each of these invisible guardians is missing. The atmosphere is so thin that stepping outside without protection would mean death in less than a minute. Lungs would gasp at near vacuum, blood would boil at the edges, consciousness would fade into the silence of the red planet. Survival, then, begins with barriers, habitats sealed against emptiness, domes pressurized with oxygen, suits wrapped around every human body like artificial skin. Yet even these barriers are fragile, a single tear away from catastrophe. On Mars, the line between life and death is as thin as the thickness of glass. The tyranny of cold temperature is another silent enemy. Mars is not simply cold, it is relentlessly cold. The warmest afternoons at the equator rarely touch 20 degrees Celsius, but nights plunge to minus 80 degrees Celsius, and winters dip far lower. Metal becomes brittle, batteries fail, human flesh freezes in seconds. Every survival system, heating, insulation, energy supply, must fight this tyranny of cold without pause. Unlike Earth, Mars has no oceans to regulate temperature, no thick blanket of atmosphere to spread heat. It is a world of extremes, a place where survival is measured in how well machines can fight against the chill. Radiation, the invisible storm. If cold and pressure were not enough, Mars exposes life to another silent killer, radiation. Without a magnetic field, the planet is bathed in cosmic rays and solar particles. On Earth, the atmosphere and magnetosphere shield us. On Mars, astronauts would live under constant bombardment. The danger is not always immediate, but insidious. Radiation damages cells, mutates DNA, weakens immunity. Over years, it raises the specter of cancer, infertility, neurological decline. For settlers, survival will not only mean building walls against the cold, but walls thick enough to resist the invisible storm from the sky. Some propose habitats carved beneath the Martian regolith, cities shielded in lava tubes, entire colonies underground where rock becomes protection. Others imagine radiation-absorbing materials, domes of ice that scatter cosmic rays. Survival demands ingenuity, because to live on Mars is to hide from the very star that gives us life. The fragile gift of water is life. Without it, survival collapses in days. On Earth, rivers and rains make water seem abundant. On Mars, it is locked in ice, hidden beneath dust, trapped in permafrost. Extracting it is possible, but costly, requiring drilling, melting, and purification. Every drop will be precious. Water will cycle endlessly, from human bodies to reclamation systems, from waste to drinking fountains, recycled until molecules blur their history. In every breath exhaled, in every bead of sweat, settlers will be reminded, survival depends on never wasting what Earth gives so freely. And yet, even if water can be mined, it must be protected. Without atmosphere, liquid water cannot last on the surface. It will freeze or boil away. To drink water on Mars is to drink defiance itself, a reminder that life survives not by permission, but by persistence. Food in the desert of dust on Earth, survival is nourished by soil enriched with life. On Mars, the soil is poisoned with perchlorates, toxic salts that choke plant growth and threaten human health. To grow food here is not gardening, but bioengineering. Hydroponics, aquaponics, and sealed greenhouses will replace fields. Artificial lights may stand in for sunlight. Plants will not grow in soil, but in nutrient baths, every leaf and root monitored, recycled, managed with the precision of a life support system. Food will never be abundant at first, calories calculated, diets measured, crops chosen not for taste but for efficiency. Survival will mean eating not what one desires, but what can be grown under glass in a desert of dust. Energy, the pulse of survival, every breath of oxygen, every sip of water, every bite of food will depend on energy. On Earth, survival is powered by sunlight, air, and forests. On Mars, survival is powered by reactors, solar arrays, and batteries. Solar energy is possible, but fragile. Dust storms, some lasting months, can blot out the sun and cover panels in choking layers. Nuclear power offers constancy, but carries its own dangers, and the challenge of transporting reactors across interplanetary space. Without energy, survival ends. Oxygen generators fail, heaters die, lights dim. On Mars, energy is not convenience, but the heartbeat of existence. The dust that never sleeps. Mars is a world of dust, fine, sharp, and endless. It seeps into machines, clogs joints, erodes metal. It carries static charges that cling to surfaces, infiltrating lungs and scratching skin. Dust storms can cover the planet, swallowing landscapes in red haze for weeks. To survive here is to battle dust as much as cold or radiation. Habitats must filter it, suits must resist it, machines must be designed to outlast its abrasion. Dust is not dramatic like storms or volcanoes. It is subtle, persistent, the quiet enemy that wears down survival day after day. The psychological precipice. Survival is not only physical. On Mars, the human mind may prove the most fragile frontier of all. Isolation, confinement, distance from Earth, these erode the psyche as surely as radiation erodes cells. Every settler will live beneath artificial ceilings, walk in suits, see the same walls, the same faces, day after day. Earth will hang in the sky not as a place one can return to, but as a memory. Communication delays, minutes of silence across space, will cut the immediacy of human connection. Depression, anxiety, conflict, monotony, these may be as lethal as cold or vacuum. Survival will depend on culture as much as technology, on the ability to create meaning, ritual, and joy in a place where nature itself offers none. The fragile chain of dependence on Earth, survival is resilient because it is distributed. If a farm fails, another supplies food. If a city falters, others endure. On Mars, survival is fragile because it is singular. A single failure, a broken oxygen system, a cracked dome, a power outage, can mean extinction. Redundancy will be essential. Every system must have backups, every failure must be anticipated. Yet redundancy cannot erase fragility. It only buys time. On Mars, survival is a chain, and as strong as its weakest link. The shadow of Earth's survival on Mars is not isolated, it is tethered to Earth. Supplies, spare parts, even medicine may need to come across millions of kilometers. If Earth falters, politically, economically, ecologically, the Martian colonies may falter too. To survive, Mars must eventually become independent. But in its early centuries, it will be Earth's fragile child, dependent on shipments and goodwill, living always under the shadow of home. The cost of mistakes on Earth, mistakes are forgiven. A wrong turn leads to another road. A broken system can be replaced by nature's abundance. On Mars, mistakes are fatal. A crack in a helmet, a miscalculated ration, a missed warning of radiation, each may mean death. Survival will demand a culture of precision, discipline, and foresight. It will demand people who live not carelessly, but consciously, aware that their lives hang by design, engineering, and vigilance. The meaning of fragility, and yet, within this fragility lies something profound. To survive on Mars is to live in awareness of life itself. Every breath becomes precious, every meal miraculous, every sunrise over the barren horizon a reminder that life endures where it should not. Perhaps this is what makes Mars alluring, the stark contrast between fragility and persistence. Survival here is not easy, but luminous. It reminds us that life is not guaranteed, that it is an act of constant resilience. Closing reflection: Mars will never offer survival as Earth does. It will always be fragile, precarious, uncertain. But fragility does not mean impossibility. It means meaning. For to survive where survival should not exist is to celebrate life at its most defiant. In this way, the fragility of survival on Mars is not only a danger, but a lesson, a reminder of the thin threads that hold us even on Earth, the invisible balances that sustain us. To live on Mars is the future of colonization and generational settlements on Mars. To speak of colonization is to speak of time, not in years or decades, but in generations. The first human footprints on Mars will be fleeting, but the truest measure of success will not be the landing itself. It will be the child born beneath a Martian dawn, the second, the third, the lineage that follows. Colonization is not survival for a moment, it is the weaving of permanence into a place that does not want us. Mars is not an inn for travelers, it is a wilderness that will demand settlement, transformation, and the steady rhythm of generations to come. The first settlers, founders of a new world, the first humans to live on Mars will not be colonists in the truest sense. They will be pioneers, scientists, engineers, explorers, chosen not for permanence, but for resilience. Their task will be to survive where nothing should survive, to carve out the foundations of life in an alien desert. But in their footsteps will come settlers. Families, teachers, farmers, builders. They will not come to study Mars, they will come to belong to it. The transition from expedition to colony will mark the birth of a new era, when Mars ceases to be a destination and becomes a home. Generational settlements, life born on Mars. Colonization truly begins with the first birth. When a child opens its eyes to the pale Martian sky, humanity crosses an invisible threshold. That child will never know Earth as home. For them, gravity will always feel lighter, the sun more distant, the air manufactured, the stars sharper against the thin atmosphere. Generational settlements will forge a new culture, a new identity. Songs, stories, traditions, all born beneath the rust-red soil. What begins as a colony will, over generations, become a civilization, Martian in spirit, though human in origin. The architecture of permanent's early habitats will be fragile, domes, prefabs, underground vaults. But permanence demands more. Over centuries, settlements will grow into cities, towers carved from regolith, green parks under sealed skies, vast tunnels stretching like veins beneath mountains. Architecture will adapt not to human vanity, but to Martian necessity. Every structure must resist radiation, conserve heat, recycle water, and withstand storms. Cities will not resemble Earth's. They will be ecosystems in engineered shells, machines large enough to house entire generations. To walk through such a city will be to walk inside the machinery of survival, where life is inseparable from technology, and technology inseparable from community. The economy of a Martian civilization colonization is more than survival, it is the birth of economy. On Mars, scarcity will shape value. Water, air, power, and even soil will be currencies as vital as gold once was on Earth. At first, Earth will supply what Mars cannot produce. But dependence will fade as Martian industries emerge, mining regolith for metals, extracting water ice, building factories that fabricate their own machines. Trade may begin between Earth and Mars, but eventually extend to other colonies, moons, or even asteroids. Over centuries, a Martian economy will no longer be an echo of Earth's, but something unique, adapted to scarcity, distance, and the constant demand for resilience. Culture in the Martian dawn colonization is not merely about infrastructure, it is about culture. A settlement is not alive until its people create meaning, rituals, art, and memory. On Mars, culture will grow from constraint. Music may echo differently in domes, paintings may use pigments born of Martian minerals, literature may explore themes of isolation, endurance, and the relationship between humanity and technology. Festivals will emerge, the celebration of first landings, of new births, of survival through great storms. Children will write poems not of oceans or forests, but of dust, stars, and the fragile warmth of habitats in endless cold. Mars will not erase human culture, it will expand it, giving birth to expressions Earth has never known. The challenge of identity with generations will come questions. Are Martians still Earthlings? Are they human first or Martian first? As centuries pass, language may diverge, customs may evolve, values may shift. Gravity itself may shape bodies differently, leading to subtle but profound physical changes. A Martian child, raised in 1/3 Earth gravity, may never move with the same gait as their ancestors. Over time, identity may fracture. Mars may see itself not as an outpost of Earth, but as something new, a civilization with its own destiny. The tension between belonging to Earth and belonging to Mars may define centuries of cultural evolution. Education and knowledge transmission colonization is fragile. One generation's mistake could undo centuries of survival. Education, therefore, becomes not just a duty, but a necessity of existence. Children born on Mars will learn not only mathematics and history, but also the art of maintaining habitats, repairing recyclers, understanding ecology in a closed system. Knowledge will not be abstract, it will be lifeblood. Martian schools will teach more than Earth's lessons, they will teach survival as heritage. Every child will grow with the awareness that their life is bound to machines, to community, and to the delicate balance of a hostile planet. The expansion of settlements, from colonies to networks, a single settlement is vulnerable. True permanence comes from networks, multiple cities, each supporting the others. Colonies may spread across the Martian surface, linked by maglev trains or underground tunnels. Each may specialize, one in mining, another in agriculture, another in research. Together, they form a web of resilience, where no single disaster can extinguish humanity's foothold. Eventually, settlements may stretch into orbit, space stations, fuel depots, shipyards, extending the Martian presence into the greater solar system. Colonization of Mars is not the end, but the beginning of a chain reaction that spreads life outward. The ethics of colonization, but with permanence comes responsibility. What right do humans have to transform another world? If life, even microbial, exists on Mars, is colonization an act of creation or destruction? Generational settlements force the question of ethics. Colonization is not neutral, it is a rewriting of a planet's destiny. Future Martians may debate whether humanity has the right to terraform, to extract, to dominate. Others may see it as destiny, life extending its reach, fulfilling its nature. This tension will not vanish, it will become a central part of Martian philosophy, shaping laws, culture, and identity for centuries to come. Intergenerational governance. A colony cannot survive without order. But governance across generations is more than law, it is memory. How do you build a political system when the distance to Earth makes direct rule impossible? At first, Earth may govern through remote authority. But in time, Mars will govern itself. Constitutions will be written, councils formed, laws adapted to the realities of scarcity and danger. Future generations may invent new forms of governance unknown on Earth, shaped by the need for cooperation and the dangers of division. Politics on Mars may be less about power and more about survival, though human history suggests conflict will never vanish entirely. Generational psychology. Becoming native to another world. Generational colonization carries an invisible weight, the psychology of being born in exile. For the first Martian-born children, Earth will be myth, a place of oceans they will never see, skies they will never breathe. Some may feel loss, others liberation. Some may see themselves as heirs of Earth, others as founders of something greater. Over centuries, the psychology of exile will fade, replaced by belonging. To be Martian will no longer be to miss Earth, it will be to inherit Mars as home. This transformation will be slow, but inevitable. And in that transformation lies the birth of a new civilization. A civilization beyond Earth. The ultimate measure of colonization is not survival, but civilization. A settlement becomes a civilization when it can endure not just for decades, but for centuries, when it can create not just homes, but legacies, when it no longer relies on Earth to define its existence. Generational settlements on Mars may one day rival Earth in complexity, diversity, and culture. They may write their own histories, wage their own struggles, achieve their own triumphs. In time, Earth may no longer be home, but origin, the birthplace of humanity, but not the only cradle. Closing reflection. The future of colonization and generational settlements is not guaranteed. It will demand courage, ingenuity, sacrifice, and time measured in centuries. Yet if it succeeds, it will mark the greatest transformation in human history. For the first time, humanity will be more than earthbound. For the first time, we will be a species of two worlds, and in that doubling, something profound will emerge. Ethical and philosophical questions of colonizing Mars. Mars stretches out before the human eye, a planet silent for billions of years. Its deserts are unbroken, its mountains untouched, its valleys carved only by ancient winds and forgotten rivers. Here lies a paradox, a place so barren, and yet so complete. When humanity steps upon it, the question is not only how we survive, but whether we should. Colonization is not only a technological challenge, it is an ethical one. Every footprint in Martian dust is a statement, every habitat a claim, every planted seed an act of ownership over a world that did not ask for us. The deeper question is not, can we colonize Mars? But, do we have the right to? The question of ownership. When the first settlers arrive, Mars will belong to no one. Its deserts will not recognize borders, its craters will not yield to flags. Yet humans are not a species that leaves land unclaimed. History reveals a constant pattern, new territories, new empires, new lines drawn across landscapes. But can a planet be owned? Should it? If Mars belongs to humanity, does it belong to all equally, or only to those who reach it first? Will nations carve it into territories? Or will corporations declare mineral rights as though it were another earthly frontier? The ethical question of ownership haunts the idea of colonization. Mars is not an empty stage, it is a world with its own story. To claim it is not simply to extend humanity's domain. It is to write over a silence that may not need our voice. The question of life, the silent witness. Perhaps the most profound ethical dilemma lies not in human survival, but in Martian existence. If Mars harbors even the simplest microbial life, the act of colonization becomes not expansion, but intrusion. What if beneath the ice, or deep within ancient caverns, tiny organisms endure? They may not think, or speak, or dream, but they are life. And life is rare. If humanity alters Mars, warms it, seeds it with Earth's biology, reshapes its chemistry, we may erase them forever. Would we be explorers or conquerors? Would our legacy be the birth of a civilization, or the extinction of an alien species? The ethical question is stark. Is human life worth more than Martian life? And if survival requires the destruction of the native, what does that say of us as a species? The question of terraforming colonization inevitably invites the dream of terraforming, reshaping Mars into a world that resembles Earth. By thickening the atmosphere, warming the climate, melting the ice, and releasing oxygen, we might one day walk its surface without a suit. But terraforming is not preservation, it is transformation. To terraform is to overwrite. To take a planet's identity and sculpt it to mirror our own desires. Is this creation or destruction? Is it the highest expression of life's will to spread, or the ultimate act of arrogance? Should humans adapt to Mars, or should Mars be forced to adapt to humans? The question is not only technical, but philosophical. To terraform Mars may be possible. But should it be done? The question of justice and inequality history warns us. Colonization on Earth has rarely been equal. It has often meant the powerful claiming land, resources, and people at the expense of others. Will Mars repeat this pattern? Who will have the right to settle there? The wealthy, the powerful, the chosen few? Will Mars be a sanctuary for humanity, or a fortress for the privileged? Will the Red Planet become a new utopia, or will it carry the scars of Earth's inequalities across space? Ethically, colonization forces us to confront our failures. If we carry greed, division, and exploitation to another world, then Mars will not be humanity's new beginning. It will be Earth's old mistakes written on a new canvas. The question of identity and separation over generations, Martians may no longer see themselves as Earthlings. New cultures, new languages, new values may emerge. When Mars grows into its own civilization, questions of identity and sovereignty will follow. Will Mars remain loyal to Earth, or declare independence? If conflict arises, will it be ethical for Earth to rule a people born on another planet? And if Martians choose a different path, will humanity see them as kin, or as rivals? Colonization carries within it the seed of division. To settle another world is not only to extend humanity outward, it is to risk splitting it forever. The question of responsibility to Earth, another dilemma, lies not on Mars, but on Earth itself. Should humanity devote vast resources to colonizing another planet while billions suffer in poverty, while ecosystems collapse, while Earth's climate unravels? Some argue that survival demands expansion, that Mars is humanity's backup, its ark against extinction. Others argue that colonizing another planet while failing to heal our own is escapism, not progress. The ethical question is clear: does our responsibility to Earth come first? Or is leaving Earth itself part of that responsibility, to ensure life continues, even if our first home falters? The question of meaning beneath all these dilemmas lies the deepest question: why go at all? Is colonization destiny or choice? Is it driven by necessity, curiosity, survival, or ambition? Philosophers may ask, what does it mean to transplant humanity across the stars? Is this the fulfillment of life's purpose, to expand wherever it can? Or is it the greatest act of hubris, an unwillingness to accept limits? For some, Mars is a mirror of human courage. For others, it is a mirror of human arrogance. The truth may lie somewhere between, that to colonize is neither wholly noble nor wholly selfish, but simply an expression of what we are, restless, searching, unwilling to remain still. The legacy we choose in the end, colonizing Mars, will not only shape the future of humanity, it will define the story we tell about ourselves. Are we caretakers of life, or conquerors of worlds? Do we expand because we must, or because we cannot resist? Future generations will not only inherit the domes and cities we build, but the ethical decisions we make now. If we colonize with greed, Mars will reflect greed. If we colonize with care, Mars may become a testament to wisdom. Perhaps the truest measure of success will not be the survival of our bodies, but the survival of our conscience. Closing reflection, a question to the stars. Mars waits, silent, unjudging. It will not ask us to come, nor will it refuse. The choice lies with us. To colonize Mars is not only to step into a new world. It is to step into a moral frontier, where every action carries the weight of history, every choice ripples through eternity. And so the question remains, not whether we can survive on Mars, not whether we can build cities beneath its skies, but whether we can carry with us the wisdom to deserve it. If we fail, Mars will one day be a graveyard of arrogance. If we succeed, Mars may become the second cradle of life, a place where humanity proves it can grow not only in strength, but in wisdom. The red horizon waits, and with it, the question that may define us. When we reach for the stars, do we rise as guardians of life, or as architects of our own extinction? Thanks for watching the documentary, folks. Like and subscribe our channel. Cathy later.